Hey guys, what's happening? So I thought I'd show you an RF project I'm working on. I kind of wanted to do this for a while, and I wanted to combine like an RF switch with the SWR meter, because I wanted to have just like a CB antenna switch, you know, but with the SWR meter and watt meter, so I knew what I was setting into my amp, you know, at all times. Plus I wanted to switch and test different radios and see like the different receive, check different receive, how well they're receiving. So I designed this box last night and I have a couple of revisions. So I wanted to combine an RF switch into an SWR meter. But these SWR boxes were horrible. These were cheap. I bought them on Amazon probably like 5 or 6 years ago. And they don't even sell them anymore, but they were horrible. They're also going, I'll put down the other names that they go by. They go by like a Workman. But look at that. That's horrible. The reason why it's horrible is, if you're not familiar with this stuff, is that those are unshielded, long, unshielded wires wrapped together. Yeah, you don't want that. You don't want, well, definitely don't want wires that long and unshielded. So I'm going to take these apart. But yeah, there was another guy that made a video about him redoing this stuff with short wires. But I'm going to redo it with coax, RG58 coax. Try to keep them shielded as long as I can. But one of the things that's going to make this box unique too is that, so I'm going to take a bunch of junk parts. You know, like the super cheap little Astatic, some SWR meter I've had for a long time. And then I'm going to try to combine two cheap parts and hopefully make some good parts out of them, you know, by rebuilding them correctly. So SWR, so I want to be able to see like the SWR and watt meter when I'm sending into the amp. But I want to at least switch between 3 radios. So this is a 3-way position switch. Another unique feature here is I want an RF tap. So basically I'm going to have a BNC, I'm going to have 3, you know, I think like SO239 connectors here. So 3 inputs, 1 output. And then I have this little BNC connector here. So I want to create an RF tap, so I can send this RF tap to my oscilloscope and frequency counter and double check that my modulation looks good and my frequency looks good, so I can see what I'm actually outputting. Yeah, these videos are totally unscripted. So I had tested it with one of my with the Nano VNA, and that's how I figured out how bad these were. You know, like the SWR is like example. So I was getting like 1.2 SWR when my antenna was connected directly to my my CB. But then when I put this in between it, it went to like 1.6 SWR. Yeah, so, I mean, I'm trying to figure out why they did this, you know, to make it easier to put together and mass produce. But, you know, in the IT world, I mean, I have a C7 contractor's license in California. And, I mean, even, I don't know, in the data world, you don't want to have like this kind of wiring, you know. You want it to be all twisted to prevent EMI in the wire. I do a lot of fiber optic, that kind of stuff. So I build data centers. Alright, so today is a new day. So I just keep on making revision changes. Because I'm trying to figure out like the best solution for like the RF coupler. So originally I had it over here in the back. And I was like, what am I going to do here? I'm going to have to rewire it in some freaky way that might pick up too much interference. Or pick up too much of the RF power. You know, with long leads, you know, going across other leads. So this made more sense to put it over here in the back, but I'm kind of running out of space for my best printer. So I want to print this on my best printer because it prints incredibly. Look at the quality of the surface here. So, alright, so I got the RF meter in there. Switches, potentiometer. So I might make this 5 millimeters bigger, the box, I'm not sure. I'm waiting for my little BNC part to come in here. Alright, so I've made a couple of revision changes here. Created a new box, I need more space for the BNC. So I'm going to start soldering in the connectors. So I'm just using little things of RG58. I mean, I could use RG8, but it's like, they're short runs. Plus this is more flexible, tinier. So I can use a smaller toroid. Alright, so you guys can see what I'm doing here. So what I'm trying to do is keep the shielding. I'm trying to keep this thing in the center contact as shielded as long as possible. The minimal amount of exposure as possible. Take a look. Alright, so I'm going to use my multimeter and do a continuity test to make sure I don't have any like a frayed wire, like a frayed ground, the coax, the shielding. It's not touching the center pin, center contact. So I'm just going to do a quick continuity test. Let me show you an example. I'm getting continuity between the center pair. See that right there? I'm not supposed to get the continuity. So I obviously have a wire frayed over and touching the center pin. Alright, so today's a new day, and kind of was messing with this last night. There's so many different ways you can do an RF sampler. Like this is by far the ideal way of doing it. Like you're supposed to be actually going over the center tap and not the outside shielding. But I'm not trying to make any accurate measurements. If I was trying to make an accurate measurement, I'd have this directly tied in here with some attenuators. I'm just trying to basically look at the modulation wave, the form. I want to see the rounded edges of the modulation to see if I'm actually modulating correctly, and even just maybe hit the frequency counter. But yeah, like I said, this is not for an accurate. I'm just trying to pick up like spurious RF emissions, just to look at my frequency counter. So run a BNC connector up to it. 27408, pretty close. So we have a little BNC here. Like I said, I'm not even taking measurements. I just want to see like modulation. Audio 1 2 test audio. See? All right, I'm gonna do lower sideband here. Audio test 1 2 test. All right, not the cleanest signal, but. So what I'm looking for is those rounded peaks, and I don't want square peaks, or some kind of clipping or something wrong with the modulation. That's just what I wanted to see. I want to. Doesn't need to be perfect. I just want to see what this thing looks like. So I put a 51 ohm resistor in there. That's all I had. I see actually they didn't even sell a 50 ohm resistor at Marvac, the place I go to. So let me show you real fast. I'm gonna just right now it's not connected, but I just want to show you the before and after as I connect it. So look on the scope. Not connected, connected. Not connected, connected. Let's try this one more time. Turn this on. Alright. I'm done fiddling with it. So if you guys, the RF engineer guys that watch my channel, let me know if I can improve this. So right now I got a 50 ohm resistor between the two pairs. Kind of similar to what I have here, but obviously this has a lot more windings and it's right on top of this contact, so I'm going to be getting a lot more signal. But yeah, I know this is not the right way of doing it because I'm actually, it's a shielded wire, so I'm actually shielded on the outside, the ground side. So, but I just need enough to see the wave. I just want to see if it's what the modulation is. I don't, maybe the frequency counter, but so if you have any better ideas, let me know down below in the comments. Alright, so I'm printing out the lid right now. That's at the very max the volume of that printer. Alright, so what's funny is I need to fire up my CNC machine router. I could do this. I could do all these boxes out of aluminum. It's not really. I mean, I already designed the part. All I have to do is buy a chunk of aluminum and machine it. Either on that CNC router or the CNC mill here. Alright, so I don't have the switch enabled, so I'm getting negative 43.85. Hopefully you can see that. I'm going to switch to port 2. There we go. Each of these scales is 10 dB, each little line. Alright, so that should be open. Negative 43 dB. Closed. Alright, so my antenna, the Stardust I have on my roof is 1.296 SWR. I mean, I could make it, I could go up there and adjust it more and dial it in better. Alright, I want to see what kind of loss I get with the SWR through this device. I mean, just to let you know that this is never going to be connected directly to antenna. This is going to, the next leg is going to be the amp. So the amp is going to be actually dealing directly with the antenna. So I might have to mess with the input capacitance on the amplifier, but alright, let's see. Look at that. I mean, that adds about 5 to the SWR. I mean, it is a switch, so I mean, I mean, you're going to have loss, but that's a lot of loss. I mean, is it just the switch? I mean, that's not a really good RF switch. It's a cheap as the cheap. Or is it the coax not being shielded? The length of the wire? You know, it is slightly better going through the straight switch. I mean, I am going through more components here. I'm going through a whole SWR meter, this whole PCB as well. So, alright, well, I'm going to hook it up, play with it, see how it sounds. Like I said, the next leg is the amplifier. You know, now that I'm on this project, and I've been thinking it for a while, I mean, I even bought a different switch, a ceramic switch, maybe to get the SWR down. I don't know, I'm going to figure, I don't know if I'm going to do that or not, we'll see. But, I started thinking, what if I did like 4 relays? That way I can actually isolate the input, ground the input, the center pin, when it's not being used, to not send feedback to the other radio. Even though this is CB, I'm not putting out, this is super low power. This is preamp. So, but it would be kind of cool if I could do like Arduino or do like a Blue Pill. And program some sort of like LCD. So I could get like a digital like a watt and SWR meter. But do it all in software, you know, with the Blue Pill or Arduino, or most likely a Blue. I would do a 32-bit ARM processor. I wouldn't bother with an 8-bit. But use 4 different, like actually 3 relays. You know, 3, yeah, like typical relays. What I'm going to do here is, see, this is a dual. I think I call it the dual, not wafer, but so I'm going to give it double the amount of contact points. I'm going to solder the rows together. So I'm going to have each section will have 2 contact points, and each contact point is dual contact. So if I can see that, so really there's going to be 4 contact points. So I don't know if that's going to be the issue or not. I think it was like 10 or 12 bucks. Alright, so I got to remove this stuff now. This thing with the coax is so stiff I can't even pull it out. So here's what I did last night. See, I actually ran like a jumper wire across all the things there to give it more contact points. It's going to be a lot harder to turn, but yeah, what's the point if you're not going to get a signal? Alright, so now you can see the difference here in the switch size. Huge difference. Yeah, I'm not sure if 100% that's what it is, but I don't know. So yeah, this project's been going on for over a week, maybe week and a half. You know, it's Christmas time. So what I need to do is make sure that I don't have any, you know, none of the contacts are shorted. So I'm going to get my multimeter and make sure that we don't have any. This one looks pretty close, so I'll have to be careful of that one. Bring that in a little bit, maybe. So I want to make sure there's no shorts between the grounds and the positive, you know, the center pin and the outside shield. Alright, so let's go over this one more time. So I got the dummy load, go into my watt meter. It's about a 6 watt dead key, 1.0 SWR. Alright, so before this thing was picking up like 0.6, 0.7 of an SWR of reflect with that horrible switch. So we'll see if all this time paid off here. Got the thing connected in, port 1. I mean, I am expecting loss, but not dramatic loss. Yeah, that's still a lot of loss. 0.7. No change. Alright, so I was doing a lot of reading last night on RF design, circuitry, input. So I guess I'll try. I'll see if I can maybe add a capacitor to the circuit to lower the SWR, because I know I'm getting good contact. Like here and here, you know, with the 50 ohm dummy load, I'm getting good resistance. So you take a look at this. Yeah, between here and here, actually. Put that into resistance mode. Well, I'm getting a good. I'm not touching down hard enough, but I'm getting a good contact with the, what's it called? You know, I'm getting good good connection between here and the dummy load. So when it's keyed in, I'm getting, you know, low resistance too. So like I hardly change. I only add like 0.1 all the way through the circuit that I've put together. So I think I need to add some capacitance somewhere in here. Alright, so I watched some videos last night, and I just happened to turn the CV down. I just happened to run across like a old BBI amps. Like when he was tuning the amp, he was adding capacitors. Like I'm new to this RF, AC RF. It's a complicated subject, but I'm learning though. So, but look at the dramatic difference I found just by adding these capacitors. This is a 44 picofarad capacitor, for it's gonna be 47. So right now I'm running at 1.793, and I went through and I actually just touched different spots. Yeah, adding this capacitor, different parts of the board here. And what's funny, I just happened to run across this video, and it was a different subject, but I just picked up and it kind of made sense. I was like, well, okay, yeah. So I went to the store, so it dropped down to 1.2234. Then I tried a couple different spots, you know, on this over here. Then it got better. I got it down to like one. I'm trying to get good contact on there. We're having it right at the input. I'm getting down to 1.189, so it gets better. But then take a look when I go right out of the antenna here, between the jacket here and here, 1.14. So I think just hooking it up to the dummy load was about 1.1 right on the dummy load. And the coax is not, I mean, it's not cheap. I guess it is cheap coax, but that's incredible. Just adding a little capacitor. You know, just basically matching everything, you know, matching the impedance. Like I said, I'm still learning this stuff, so interesting. It's actually a complicated subject, man. It's crazy. Alright, so it's time to put this thing back together here. So, I don't know if I mentioned this. Like I said, this I've been working on this for a couple weeks now. So I added this capacitor here, this 47 puff capacitor here, 47 picofarad, just because I can see with my nano VNA the resistance level. I'm going with multiple SWR meters. And what's funny is it really is. It's like almost like you need to tune every device in the chain. So for me, it goes from my Stardust M400 to that meter, and then it goes to my amp, then it's going to my thing here, but then I'm taking this out of the equation. This was the digital meter, but it's almost like you need to tune everything in between. You know, like I said, there's a tuning capacitor on the input capacitor on the amp, but to get the lowest SWR, you got to like tune almost every device in the chain. And what's funny is every single radio is different, because what I was getting between these two radios was totally different. So I actually had to tune it for the radio in the chain. Alright guys, first phase is done with that antenna switch. So this was the original idea, was so I could go back and forth between my radio. You can see the antenna go off. So I can use my best antenna for my SDR console. You know, I'm running SDR play down here. So I have an HF, you probably can't see, but I have an HF antenna on one, 40 meter antenna. And then, and if I just want to transmit, you know, it's got to go down here. But I also have a third. I have a third, so I could actually have like an accessory if I want to test the radio right here. Run an antenna, or I could use my other antenna, I guess, but alright, let's make sure it's on one. Yeah, that's one right there. And I'll just do a quick, let's do like some channel that's not available right now. AM. And let's see, to turn on the amp. Get raw mic. Get present. Audio check, audio check. Yeah, so you can see like what I'm sending the thing in there. So I'm putting 4 watts in and I'm getting 100 watts out, or 90 watts out. So I always wanted to see what I was driving the amp with, you know, so I know I'm doing 4 watts. So pretty cool. Yeah, I learned a lot about, you know, RF theory and like AC theory, and like I said before, it's like I've never used capacitors in that way before, you know. I've always pretty much worked on the DC side of things, so pretty cool learning experience, you know. Like lowering down like the inductance and capacitance, and just, you know, kind of mind-boggling. But all right, cool. So yeah, I wanted to be able to sit there and run this. That's really the main thing. I wanted to be able to run this thing. So all right, cool.